Let me go back to Wigner's thought experiment again, because I think this is a good hook for where I end up and where I think a lot of people end up. So what was this thought experiment about? In a way, I mean, it's a thought experiment that a lot of people in physics and certainly philosophy of physics are familiar with. It's a real good workhorse in quantum foundations. But I think there's still a lot of lessons to learn from it. And people have extended this thought experiment in lots of different, there's the so-called extended Wigner's friend scenarios that a lot of people are working on. But I think the original version of it is actually really, really nice. And like I said, phrased all the way back in 1956 in Hugh Everett's original thesis. But it's a very simple question. The axioms say that we have a Hilbert space and we represent the state of the system as some object in this Hilbert space. Questions we can ask observables are represented by these symbols. We can generate probabilities, and then after a measurement, we collapse. Why do we collapse? What's the purpose of collapse? Collapse is to ensure robustness of measurement results. After you do the measurement, you're guaranteed to get the same result again. That's what collapse accomplishes. It ensures that once you've gotten a definite result, if you measure right again, before you've given the system any chance to evolve further, you're guaranteed with almost 100% probability to get the same result. Now, the problem, of course, is that, well, what is a measurement? What kinds of physical processes count as measurements? One view is we don't need to worry about this. One view is all scientific theories are ultimately instrumentalist enterprises, meaning that they exist solely to allow us to connect preparations, setups of measurements to predictions of measurement outcomes or measurement results. That's all a scientific theory is meant to do. Doing anything else, painting pictures of reality, is all just there for color. It's like a fable. It's not necessary. It's philosophy. It's metaphysics. It's not important for physics to do that. And the theory does that. The theory says that we do a measurement, here's what comes out. The theory is doing what it's supposed to do. What more could you ask of it? The theory says when we do a measurement, we do this thing, we run this prescription, we collapse the state of the quantum state of the system, and then we proceed. It all works just fine. What's your problem? The Wigner's friend thought experiment considers two observers. One is Wigner in the outside world, enjoying a nice sunny day, maybe a nice beautiful autumn day like today. And Wigner's friend, who is inside a perfectly sealed box. Now, people may wonder, in quantum mechanics, can you really seal anything in a box? Can't things tunnel out? Well, particles can tunnel out of certain kinds of enclosures, but if you make the box thick enough, impenetrable enough, in some highly idealized sense, then you can keep everything inside the box, at least for the duration of the experiment.